Okay, that's the first time I saw this picture. Nobody consulted that with me, but it's nice. Cool, thanks. So basically, I sent the call for papers form. I got accepted, but when I started working on slides, I realized that the topic is too big to actually fit on the slide. So let's just assume the topic goes like this: releasing Android apps and not getting fired. I'm Mateusz. I'm working as the Android technical lead at IG. I'm also GDG Krakow co-organizer, and I'm the member of the Google Developer Expert Program on Android. And oh, wow, it's fourth time here. Hi again. So a lot of things changed in my life since I was here for the first time. So those are my twins right now. This is how they looked a year ago. 2 years ago when I was speaking here, they were like this. And 3 years ago, I was just a single and simple party person. Now it's completely different. And in 2016, I was speaking about the MVP. In 2015, I was speaking about the full text search in the SQLite. And in 2014, I was speaking about Guava on Android. Well, in 2014, believe me or not, Guava was still a thing on Android. And actually, people liked the presentation. I believe I wouldn't get accepted with that topic anymore. So, and this year, I wanted to do something different. I wanted to talk not about building stuff, but about how the stuff is being shipped. So shipping is actually pretty important because the code that you write in your Android Studio or any IDE of your choice is pretty useless if nobody is using it, right? So basically, shipping process is actually a fundamental thing right now, a fundamental thing in the software engineering, and it always was. But actually, if you go to multiple conferences and so on, there are actually not that many talks that are mentioning on this topic. So this is why I'm here. And this is why I'm going to talk about this specifically. So to give you some context, for the last 2 years, I'm working in IG as a developer of the trading application, right? And we are a pretty big company in terms of the amount of transactions that are being made. And 25% of them are done through the Android app. Actually, recently we reached the milestone where people started to trade more on their mobile than they do on the web, which is actually amazing. And the risk of the brand, and actually the monetary risk, the overall risk is huge if things break in this app, because every second we are processing some transactions within our Android app. So yeah, maybe we are not Facebook or not Twitter, but those numbers aren't maybe that much impressive, but we basically need to be super careful. Why we need to be super careful especially is because releasing the mobile apps is quite tricky. So if you introduce a bug on mobile, there will always be somebody who will never ever upgrade again, right? So once you push something, it stays there everywhere. It stays there all the time at least for some time, right? Till you reach like a 1% of the adoption on that particular version, and you can basically forget about it. So it's much harder to fix bugs on mobile than to fix them on the backend, for example, like from this perspective, right? So, and the crash actually that happens on the mobile app isn't the worst thing that can happen. Who thinks that the crash is actually the worst thing that can happen? Like, think about the worst production issue that you ever had as a mobile developer. Was that a crash? Maybe for some of you it was. Actually, like, if you crash on the login flow, it's actually pretty major outage, right? But I will tell you a story about something I have done 5 years ago when I was working for a different company, and actually I'll tell you about the day when the Android code killed Android, iOS, and the web. So basically we had the offline app that was periodically syncing with the web, and when user changed some stuff locally, It was stored into the database with some special updated flag, so we marked it as something that we need to send to the server. And once this was stored in the database, we were triggering the sync adapter by then to basically send the stuff over to the database in sync, and also download the stuff that was done on your account by some other people, for example. So this was like a two-way synchronization, like solving conflicts, all this kind of stuff. We had to deal with that. But the key was that when the changes were synced from the server to the mobile, we weren't setting this updated flag to true, right? Because that would automatically trigger sync again and would basically cause a loop. So, oops, this is basically what we have done, and what we got as a result was a massive DDoS attack on our infrastructure that day. So I would prefer every single crash, even the crash on the login, so users are not able to use your application, rather than this. Imagine how hard was it to roll back it from the production. Like, the bug was there, even if you shipped the fix, because if the fix was actually trivial, users will still need some time in order to apply it, right? And you cannot afford being down for days. So how did we fix it? And typical way of fixing such bugs on mobile is that you need to realize where the bug is. So in our case, we realized, okay, there is a bug in our synchronization process, and it's on Android. And now, the crucial part. You stand up from your desk, you hold your hands up, and you scream, guys, I just broke production and nothing is working, and it's because of me. Right? Why this is so important? Why this is so important? It's so important because when you are down, every single second counts, right? And then, immediately, the backend emergency team joins on the problem and tries to figure out the solution, because actually the backend was the only place we could apply the fix. After you have a workaround working on the backend, you should actually go to the mobile app, fix the root cause, and push the fix to production. And then months after, actually, yeah, you should have some tracking on the backend to actually see how many people are still affected by this bug. Once this number is not so critical, you can either leave the fix forever, the workaround, but you can actually accumulate plenty of such fixes in your code over the years, or you can just deprecate it because it's not already a threat. So what we did on the backend was actually a feature, not a workaround. So we applied a throttling mechanism that was dropping 9 calls out of 10 made within some time threshold. So yeah, that was probably the most horrible day I had in my whole career. So now, in IG, when we are doing a dealing application, we cannot really afford breaking things up. If we go down for an hour, we can be doomed. Like, our reputation will be in a terrible shape, clients will move somewhere else. Really, like, even an hour of the outage for such a critical product, when people basically need to log in the app and execute the transaction real quick because they might be losing money, this is a deal breaker for them. Another truth is, though, that our competition doesn't sleep. So on the other hand, we need to move fast. We need to build features. We need to ship often. In our case, we are shipping the Android app every a week and a half or 2 weeks, and every version is actually doing something more than correcting a typo in the stream, right? So the velocity of development is actually pretty high. So how can we make sure that managing this velocity, we can still survive and not break things up eventually, right? So the first things first, automation, right? Obviously, we have a different layers of our tests. We have the unit test, we have the integration test, and we have the acceptance tests, which are the UI tests that I want to focus on. Because this is actually the last kind of a barrier between the code to ship it on production. If those tests pass, and the exploratory testing by the QAs also pass, we actually go live. So our UI tests, no surprise, are using Espresso. and we run them in something called Firebase Tesla. So how many of you, raise your hand, how many of you know Firebase Tesla? All right, maybe around like 30%. So I will explain how it works in a second. For every single pull request before we merge it, we run those tests on 3 different physical devices in the cloud with 3 different Android versions, and QAs are actually responsible for them. So our QAs, when they were joining the company like years ago, they started testing mobile apps doing that manually, right? They had a build that was built in Bamboo. Like, they were clicking through the app, and they were basically saying, OK, I'm happy to merge this into the mainstream branch, because our QAs are actually testing stuff before it's merged. Each branch has a branch on the Hockey app, because this is what we use for the app distribution. And they basically clicked through it and making sure that everything was working. You can actually tell that this has like a huge disadvantages, right? Because it depends on the developer to actually say everything about the scope of the application that it can be impacted by those changes. And the problem is that even developer cannot know exactly that I changed this code, I added this feature, and some other feature, like a deep in the code, like in a different place, just broke, right? So this is why this automation is so important. And right now, QAs are responsible not only for maintaining this and for checking the result and for seeing what is broken, but QAs are actually engineering those tests. They are writing those tests. Some of them joined as the manual testers. We taught them how to code. So if you have a QA team which is doing mostly like a manual testing, it's really, really possible to make them involved into the automation. Because QAs are actually the guards of the quality of your application, at least they should be. And automation is something that has the same task, right? So the QA team should be actually involved in that. So we achieved this. Feels pretty satisfying, because all this boring work for basically doing and maintaining those tests is actually right now done apart from the development. So QAs are working with developers side by side. Developers working on the feature, QAs are doing the automated tests. So about the Firebase Tesla, because some of you weren't familiar. So this is basically a service offered by Google as a part of Firebase, which is like a collection of the devices that you can run your test on, run your instrumentation on. It supports like a common Android instrumentation. And it's easily integrated with any CI that you have, no matter if it's Bamboo, Jenkins, or Travis, it will work just fine. It's just a single command to actually send your APK file to the cloud and invoke those tests. What you get is, like, obviously, apart from the test results that are pretty detailed, you get full lookout, you have a video of execution, and the coolest thing, you don't have to care about it because it's always working. Like, before that, we had our devices always connected to some local Bamboo machines that were building stuff, and there was always something broken. Like, always somebody accidentally pulled the cable with the device, and out of sudden your tests weren't running. So right now, we basically moved all the effort that we had in order to maintain this infrastructure to the Firebase, and it's actually much, much cheaper than to maintaining this yourself. Beware, like, not every test suite is actually designed out of the box to run on the test lab. So there is a cap. It's probably 15 minutes for the virtual devices and like 20 minutes for the physical devices. Once you run out of this, your test execution is actually stopped. So when you are working with those UI tests and when you are invoking them in the test lab, you need to make sure that they are actually pretty quick. So this is how it looks, more or less. Sorry for Polish here, but I cannot really know how to change the language of a given page on Google without changing the language of my entire account. So this is how it looks. You have all the test execution reporting here. You have a video you have the information, what was the rotation of the device, how long it ran, what was the locale, and so on. And this is actually the integration of, this is actually the screenshot from our Bamboo. So you see that all those results from the Firebase test lab are being streamed back to Bamboo, and Bamboo now parses them and displays them in the same way as, for example, your JUnit tests. So this is a table that for those of you who are sitting there in the back, you probably don't see anything, but this is actually the list of devices that are being supported by the Firebase Test Lab. So you have the Nexus devices, you have Samsung, which is actually like majority of the market. You have both virtual devices and physical devices. Physical devices are more expensive to run your tests on because it's like a $5 per an hour of execution versus only $1 for the virtual devices. And you also have like the OS version. So basically you can run your tests starting from KitKat to the US Android version always. And this is how it works, right? You basically install the G-Cloud bundle on your build machine and you invoke this. And in this particular case, your tests will be executed twice. For the first time, it will run on physical Nexus 6 on Lollipop, and then on Nexus 7 on KitKat. You can also specify the locale and the orientation. Apart from that, it's unfortunately not easy to get UI tests right. So how many of you are write like a test in Espresso or any sort of the UI test? Raise your hand. How many of you actually consider that this is troubling? That's for no reason the tests are not passing, or you need to fight with the recycler view to actually make them work? Do you have like such problems when you are fighting for 4 hours trying to make it pass because you know it should pass? Like at least anyone, raise your hand. Okay, there are some people who have this problem. And in our case, the problem was that our app is obviously hitting the backend environment. And those devices, no matter if it's a test lab or is your local device connected to the build machine, internet connection can go bad, right? On this device, on this particular device. Also, this makes them really slow. So basically what you get, rather than always green tests when everything is working, from time to time they were red. And if your tests are red, from time to time the people start to ignore it. They just see the error and they just, okay, let's rebuild. Right? So you need to make sure that they are failing only for the real reason. And also, sometimes when you're writing such tests, it's like, and they're hitting the real environment, it's extremely hard to replicate some edge cases on the server or some error messages, right? For example, I will show in a second, like a suspended account. I want to make sure in the UI test that basically when my account is suspended, I will get a dialog telling exactly that my account is suspended. So this is why we introduced the mock environment in our tests. So this is like a small framework that our team wrote that is basically a wrapper over the mock web server. And we are, for each test, we are actually telling what is the mocking strategy. So in this case, it's a suspended account. And then we basically take some JSON response from the server, we put them into the configuration file. So mock web server now knows, after this first line is being executed, that basically what this mock server needs to return is actually the information that your account was suspended. And yeah, we still need to run those tests on the real environment because our understanding of the server that we express by the mocking behavior can be different by actually behavior of the server. Right? So those tests are much slower because they need to hit the real environment, but we run them on like a nightly basis. An environment is just a param to the runner. So we have like a free environments, like obviously we have a production, but we also have like RC, which is sometimes not working. We have the test environment when all the development is being pushed. So basically with a single change to the instrumentation command, you can just change the environment, and then this given my mocking strategy is step is basically ignored. But what kind of a level of confidence you gain from AR acceptance test? Is it 100%? If that would be 100%, then you would basically, you wouldn't need to run your app. Tests are green, you are ready to ship. right? But for the mobile apps, it's not that easy because we have over 10K, the average Android application runs on like over 10K devices. Average Android app supports like 5 major Android versions in dozens of countries, right? So what can fail? My tests are green. So Google a couple of years ago introduced stage rollout, and I wish I would have this tool when we introduced the bug I was talking about at the beginning of the presentation. So this is more or less how it looks. You push the stuff, you deploy to 10% of the people, and you monitor things, right? So basically, our stage rollout is on those phases. First, we ship to 5%, 10, 20, 50, and if everything is OK, we go to 100. Every 24 hours, we basically increase the threshold. If crashes are fine, if the crash ratio is OK, and main KPIs are OK. So like a number of logins, number of signups, number of trades. So this is an example where actually the crash rate isn't telling you about. Imagine you have a login request and you introduce the version of the app that, for example, for some country like Japan that you didn't test before shipping, you send the wrong request, right? The application doesn't crash. Your crash ratio is pretty low, but still users in Japan cannot log in. So this is why it's so important to analyze the behavior of your application and of your users. So basically, if you look, for example, in our case, on the number of trades, this is more or less this kind of a chart, right? So peak hours, then it goes down, peak hours again, then it goes down, and so on and so on. But then you ship the app, and you see that on the day you ship the app, those mountains are a little bit smaller, right? So you start to wonder what really happened. Like, were any political events, and people are, for example, feeling worried about trading, and they don't want to trade that much. But what usually it means is that something actually went wrong. So analyzing those KPIs is actually extremely important, and usually you can gain like more signals about stuff being broken than from the crash ratio alone. Yeah. So you know AppDynamics? So we use AppDynamics to basically track things like a network requests and basically the KPIs I was speaking about. So it's extremely easy to integrate. You just apply the plugin within Bamboo and you specify your key, and basically it instruments your HTTP code if you are using some like a most popular HTTP clients, this will work out of the box. They're adding the interceptor to your OK HTTP, and they're logging stuff about timings and so on. Like stuff like authentication tokens and so on are obviously not included by default. Also, what you get is like a crash calculations and a bunch of other standard analytics tools. So for example, you can track the events in case something happens. So this is more or less how it works. So this is pretty important request that we have. Is either login or dealing. So basically, you can see that we had like this kind of a number of requests, and here are the errors. The good thing is that this tool is also integrated with our backends. So now, if you click over here on those 36 errors, you see, for example, 500 error from the server. Then you are able to correlate this with the exact 500 returned from the server, and you see, for example, Java stack trace, because the backend is written in Java. So it's extremely useful. And if these numbers goes higher significantly, you know that something is wrong. Important thing about the stage rollout that when I'm speaking to people, sometimes I feel that we have a disagreement on is that stage rollout is not a beta channel. Breaking things for 5% of people isn't good. Because among those 5% of people, there might be your most important customer that is actually generating you 30% of the revenue. Right? So you shouldn't, and you basically cannot use the stage rollout as a beta feature, and you shouldn't lower your QA standards because, yeah, it's just 5% of people. Right? So if it will break, we'll just push a new version of the app, but it's still only 5%. You shouldn't approach this problem in this manner. So, but still using it, because there are things that you cannot actually predict. I mean, you can minimize the things that you can predict, but this is like the last stage that makes you safe. So you are not letting a single mistake to kill your app rating, customer trust, or your business, right? Because if you will be breaking things constantly, your customers will turn back to you and will go somewhere else. So feature flags. That's yet another thing that we use in order to make sure that basically what we are shipping is in good health. And also this is making our development process easier. So how much time does it take to ship a feature? Like you get a specification, you go to production. It takes some, right? Depending on the feature, it can take like 4 hours to like 2 years or something. So you have multiple strategies of working in development, of working with your version control systems, right? So the first strategy is that you are basically merging all stuff to master all the time. This is also known as Git YOLO. And you are basically, what doesn't work in this approach is that when you are merging stuff to your master branch, this master branch isn't always shippable. You cannot just build it and go to prod, right? So this is not perfect. And there is another strategy, which is like a long-running feature branches. So Git flow is basically working with such a thing, right? So you are creating a feature branch, you work on a feature for how long is necessary, and then you make a huge pull request with all your work you have done in the last 2 months, and it gets eventually merged after you resolve all those 180 comments. But there is a third approach, which is actually the mix of the first and of the second. So what we wanted to achieve is you are able to constantly merge stuff so all the other people can actually benefit from it. Because if you have like a long-running branches, there are like two, let's say, sub-development teams working on 2 separate features. And they are not working only on this feature. They are refactoring some stuff in the different parts of the application, exposing some utilities and so on. And when they work in the separation for like 2-4 weeks or something, they might end up having like a huge conflicts all together, or doing the work that was already done on the different branch. So we wanted to have like a continuous integration of everything we are doing. So basically, all the branches that we have are at least like 3 days old. So we introduced like a development feature flags, which are like a compile time flags. So you are basically able to start with this flag, so it's disabled on the production builds. Then merge the stuff to master, and you can still release from master branch because the feature that you are working on is not yet finished, isn't going to be displayed to the customers. You can even work in a way that with the proper Gradle configuration, this is the code, the executable code isn't going even to be included within the output APK. So I really recommend visiting this website. So it basically tells about like concepts of working with the version control system, not only Git but in general, and it's basically very helpful. And for me, it was like a huge step forward from the regular Git flow. So development feature flag can be a shared pref, it can be compile time constant. So just as I said, you can have like a Gradle configuration that is not included. Because some features, for example, may be secret when you are working on them. You don't want anyone to actually know about them before they are shipped, because there is like a huge marketing campaign, right? So when you attended the last talk here, somebody could possibly recompile your app and turn some unfinished features on, and then you could have like a bad press that, all right, those guys are going to ship something in 2 months. So yeah, let's write about it. My biggest concern when I started working in this approach, and when I initially read about it, is that it will basically generate a huge ethology. So we will be checking for this flag like in every single place. The thing is that you don't really need to do that. In majority of cases, it's just one of two places when you just need to hide an icon, hide the item in the menu. And then when we go live, the development feature flag turns into a feature flag that behaves slightly different. So it has a similar behavior. It's basically responsible either for turning the feature on and off, but you control it remotely, right? So basically, you ship stuff. If it breaks, you turn it off. It's applied immediately. You are safe to work on the fix. You can switch it on and off per the app version. In a second, I will tell why it's super important, or per country. So, for example, imagine that you are working on a feature and it's not finished because you are missing the translation for Japanese, right? And you can control also the percentage, so you don't have to roll out to like 100 people at the same time. So we use those feature flags for A/B testing, for making sure that feature works technically, but that it works also business-wise. That, for example, if we do some changes around dealing, we need to make sure that people actually deal more after this feature was introduced, and this is like not breaking their usual flow. And the product owner is there to decide when it's ready, right? So stuff is always there in a shape that can be always shipped on the master branch when the product owner says, I think this is ready to go, I think this is MVP, I think this is enough. He or she can just turn the flag on and we go live. For this, we use a tool called Sverf. So it took me a year to learn how to spell it properly. And generally it's a marketing tool that we are abusing in a way that we are actually using it also for the technical stuff. So they have a good support for A/B testing and incremental rollouts. Because, well, this is very important from the marketing perspective and testing the product. And we use it in the addition to our internal toggle solution that actually lets us control by the country. So the combination of Sverf and our internal solution actually lets you roll out per country and by percentage. So I recommend looking on it. The interface is like a super simple, and it can actually reduce your work that you would need to do otherwise in the backend. But I'm certain there are some other tools that might be better than this particular one. And the changes that you made there are pushed via the Firebase Cloud Messaging, and they are immediately on the device. So users don't necessarily need to kill the app. The common mistake, though, is this. We actually did that once on production, and it was quite of a trouble. So we ship a version of we ship one on 1.0 that doesn't support a feature X, like credit card payment, not translated to Japanese, right? You ship 1.1 that has those translations, but then you turn the feature flag on. What happens? Users that didn't upgrade get this feature, but in English. And believe me, displaying stuff in English in some particular countries is it's a dramatic faux pas. And that's bad. So this is why it's important for those flags to have an ability to control the version to which you roll out. So a couple of conclusions. Automate as many things as you can, especially things that are hard to test, because they are time-consuming and they are hard to spot because they are not like a super popular features. Prioritize your automation by amount of time you need to spend to test it manually, right? So for many of you, your automation will actually not maybe look brilliant. Maybe you will not have a brilliant coverage. Then it's good to start anyways and prioritize it by, for example, I need to spend like the entire day to make sure that it still works. That's a good candidate for the automation. Make your remote feature flags to be checked in the real time, so users don't need to go to the settings and kill their app for the new setting to be applied. And very important thing, don't treat crashes as the only measurement of the app quality, because it might go much worse than this. And make sure your tooling is actually supporting you in knowing about the issues before your customers notice them. So every time customer is reporting the bug, a major bug that you didn't know about upfront, there is something wrong with your tooling. So that's it. Any questions?